Edexcel Corpio, Calculus 2, Improper integrals. Integrals with finite limits, the convergent case. An improper integral is one where we are attempting to evaluate an integral which may present a problem. Specifically, at least one of the limits is infinite, or the function approaches infinity at some point in the interval that we are using. So in this example, we'd like to integrate 1 over x squared between 2 and infinity, and we will consider this using a GeoGebra file. So here we're going to look at two examples. If first we can look at the area bounded by 1 over x starting at x equals 2, as we make the top limit bigger and bigger, we can see that the area appears to be getting bigger and bigger as well. However, if we now look at the 1 over x squared case, so the area bounded by 1 over x squared starting at x equals 2 and the top limit b getting bigger and bigger, it does appear that the area is converging and getting closer and closer to a half. But what we need to do is to demonstrate mathematically that that is the case. So as we saw in the GeoGebra file, we'd like to integrate the function 1 over x squared from 2 to infinity. This can be done by integrating from 2 to a value a and considering the limit of this integral as a gets closer and closer to infinity for 1 over x squared dx. So it's the limit as a gets closer to infinity of minus 1 over x, having integrated there from 2 to a, which is the limit as a tends to infinity. I'm now subbing in the top and the bottom limit. So subbing in the top limit a is minus 1 over a minus 1 over 2. And now, as a gets closer and closer to infinity, we know that 1 over a will get closer and closer to 0, and therefore the area we are looking for does converge on the value 1/2. So this integral does converge, and it converges towards a half. In a separate video we'll be looking at divergent integrals. So the process here was to replace the real limit or the proper limit of infinity with a variable a, and to consider what that integral would be for a, and then to look what happens when the limit tends to the required value of infinity. In the next session we're going to be looking at integrals with infinite limits, the divergent case.